Hi, welcome back to this channel. In this video, we will focus on the subtopic 2.2 calorimetry. These are the learning objectives in this subtopic: heat capacity, which will represent by the symbol of capital C, and specific heat capacity is represented by the small letter c. So both learning objective B and C going to ask us to determine the heat change. So basically the symbol for heat change can be either in delta H if it is request to calculate in the unit of kilojoule per mole, or the unit of Q if it can be in the unit of joule or kilojoule at any amount. So, and then in this subtopic as well, we learn two types of calorimeter. One is known as bomb calorimeter, which also known as constant volume calorimeter. Another type is constant pressure calorimeter. In other words, is the simple calorimeter. Heat change. Now let's go through the basic principle in the calorimeter. Basically, like previously we mentioned that in the reaction that may happen in both bomb calorimeter and also the simple calorimeter is either is neutralization or the combustion. And then both these reactions are exothermic process, so at where the heat will release to the surrounding. So basically all the heat released by the reaction of the neutralization and combustion will absorb by the surrounding. So based on the based on the structure of the calorimeter, the surrounding can be referred to the calorimeter. But sometimes the calorimeter will consist of water or the solution. So means that the heat released by the reaction at the same time also will be absorbed by the water or solution in the calorimeter. So when we use the Q to represent the heat release for any amount of the substance that involved in the reaction, then we can see this one is the specific heat capacity, which the unit is joule per gram per degree Celsius. So, and then this one is the refer to the mass. So the unit is gram, and then delta T is the change of the temperature is degree Celsius. So then from here we know that gram and per gram can be cancelled out, and then degree Celsius and per degree Celsius can be cancelled out. So that's why only left the unit of joule, which is the heat energy. So in other ways, if the specific heat capacity is not given, but the capital C, which is heat capacity, is given. So when heat capacity is given, the unit is joule per degree Celsius. So for this one, delta T again is degree Celsius. So degree Celsius and per degree Celsius cancel out. Then we left the unit of joule, which again also represent the heat energy. So means that the heat absorbed by the calorimeter, water or solution is either represented by the mc delta T or C delta T depends on the question, whether small c is given, specific heat capacity is given, or heat capacity is given. Before go to the calculation question, then maybe now we need to look at the difference between the specific heat capacity and heat capacity. So basically, when we look at the unit here, specific heat capacity is with the unit joule per gram per degree Celsius. So that means it's the heat energy required to raise 1 gram of the substance by 1 degree Celsius. That means we have to consider the mass of the substance. Okay, so and then the other one is heat capacity. So basically the unit for the heat capacity is joule per degree Celsius. That means they already consider the the quantity. So in other words to say, or we can say that this is any amount of the any amount of the substance based on the question or the reaction. So basically we try to check like this. If the question gives us a specific heat capacity of water, so you have to keep in mind that we are going to use mc delta T. So the mass that we're going to look for is mass of water. If other ways round, for example, if the question says this is the specific capacity of aluminium, for example, in the question we see the word aluminium, so means that this the mass that the value that we substitute in must be refer to the mass of aluminium. However, if heat capacity is given, we no need to look for the amount or the quantity of the substance. So we can just substitute in the heat capacity with the change of the temperature. You may get the clear idea when we discuss about the calculation question. Basically, when we're doing the calculation, there are a few steps that we need to follow. Basically, we have 3 steps. Step 1, we need to find out the heat released by the reaction. So basically, again, the heat release, okay, so I simplify here, heat release always equal to the heat absorbed. So the heat can be absorbed by the calorimeter or water or solution based on the situation. So step 2, we are going to look for the number of mole. So will be depends on what is the enthalpy that you calculate. If you are calculating the enthalpy of the neutralization, so we are looking for number of mole of water, because based on the definition is when 1 mole of water is formed from the reaction of neutralization reaction. So if the reaction is involve enthalpy of combustion, so the number of mole that we are looking for is the substance burned, because the definition for combustion is when 1 mole substance is burned in excess oxygen. So then next step will be step 3, which we need to calculate the heat in the kilojoule per mole, and where the symbol is always delta H. Okay, basically step 1, we're going to calculate the Q. Okay, step 2, we look for the number of mole. Step 3 basically is referred to delta H. That means next we are going to use the comparison. For example, step 2 here, we calculate the number of mole is 0.1 mole, while the Q is negative 100 kilojoule, just for an example. So delta H, in other words to say, is in kilojoule per mole. So that means how much of the energy will be released when 1 mole of substance So we will use the comparison when there is 0.1 mole of substance is burned. For example, it will release 100 kilojoule. So if now we need to burn 1 mole of substance, how much of the energy will be released? So as here we can simplify, this is referring to the N, and then this is referring to the Q. So to find this question mark, we will always use 1 times Q over N. So 1, because this one is kilojoule per mole, so always is equal to 1. So in other words, so say is Q over N will always equal to enthalpy of the combustion of neutralization, and then the unit is always in kilojoule per mole. Because the unit here can be in kilojoule or joule, and the number of mole is mole. So that's why the unit is kilojoule per mole. After get some idea how to answer the calculation question, then let's start with the tutorial question number 3. When Y matter is combusted in a bond calorimeter which containing 2 kg of water, the temperature of the water rose from 23 to 26 degrees Celsius. So from here we know that the temperature change is equal to 3 degrees Celsius. Heat capacity of the calorimeter is 37.8 joule per degree Celsius. Heat capacity is referred to the capital C. Calculate the heat released in kilojoule. Since the question doesn't emphasize in kilojoule per mole, so means that actually the question is asked us to look for the Q value. So as we know, the heat will be released by Y, and then all the heat released by Y will be absorbed by the water, because the water is surrounding the is at the surrounding of the container, okay, and also the insulated container. So means that the heat will be absorbed by water and also calorimeter in this case. So next one here, the heat absorbed by the water. Since we are given the mass of the water, which means that we are going to use mc delta T. And then for the calorimeter, heat capacity is given, so means that we are going to use C delta T. Mass of the water need to convert to gram, so which will 2 kg will equal to 2000 gram. And then the specific heat capacity for the water is 4.2 joule per gram per degree Celsius. And then the change of temperature is 3 degrees Celsius. Plus the the heat capacity of the calorimeter is 37.8 degrees Celsius. 37.8 joule per degree Celsius. And then multiply with the 3 degrees Celsius. So as we know that joule and per gram, gram and per gram can be cancelled out. Per degree Celsius and degree Celsius can be cancelled out. Here also the same case, per degree Celsius and degree Celsius can be cancelled out. So you press the calculator, you will get it is 25313.4 joule. But because of the question asks us to mention in kilojoule, so that's why we will convert it to kilojoule by divide by 1000, so it's 25.3134 kilojoule. So because here already write down the word heat released by Y, so at here you didn't show the negative sign is okay. But let's say if you use the Q equal to if you didn't write down the word heat released by Y, but you use the term Q equal to, so you have to put negative 25.3134 kilojoule. Or you also can put negative Q equal to 25.3134 kilojoule. As long as from your answer there, we can get the idea heat release, then will be okay. Proceed to tutorial question number 4. A combustion of 3.5 grams of ethanol in a calorimeter with heat capacity 15.2 kilojoule per degree Celsius. So heat capacity is capital C, so means that this is the for the calorimeter. 15.2 kilojoule per degree Celsius, and cause the temperature increase from 19.88 to 26.18 degrees Celsius. From here, we can determine the change of the temperature. So calculate the enthalpy of the combustion. So as we know, if this is the enthalpy of combustion, means that the unit must be in kilojoule per mole. So in other words to say, the question is asked us to determine the delta H C equal to how much of the energy. Okay, then before we proceed, so we know that this one delta H is in step 3. So means that we are going to start from the step 1. So step 1, we need to calculate the heat change. As we know, this is combustion, so it's heat release. So I can simplify with using the symbol negative Q will equal to heat absorbed by. So from the question here, we have no information about water and also solution. Even though theoretically, we know that we have to include the heat absorbed by water or solution. However, these two information are not given, so we can ignore them. But the information of calorimeter is given, so means that heat release of the reaction equal to heat absorbed by calorimeter. So in the question now here, the information about calorimeter is heat capacity of the calorimeter capital C. So means that we are going to calculate C delta T. So the C given in the question is 15.2 kilojoule per degree Celsius, and then going to multiply with the change of the temperature. So per degree Celsius and degree Celsius can be cancelled out. And when we press the calculator, the answer is 95.76 kilojoule. So we already settled for step 1. So now we're going to proceed to step 2. So for the step 2, as you already know, when we want to find the number of mole, since this is enthalpy of combustion, so the number of mole that we're looking for is number of mole of substance burned. So in this question is combustion of ethanol, means that we're going to determine the number of mole of ethanol, which is C2H5OH. So we use the formula mass over molar mass, 46 gram per mole. Gram and gram can be cancelled out, so end up the number of mole is 0.0761. Okay, from the previous slide, we already complete step 1 at where the heat release is 95.76 kilojoule, and then we also done for the step 2, determine the number of mole of ethanol burn, which is 0.0671 mole. Based on the question, we want to look for the enthalpy of combustion again, which is stand for the delta H, and then will be in the unit of kilojoule per mole. So that's why in step number 3, we're going to do the comparison. If we burn 0.0761 mole of ethanol, it will release 95.76 kilojoule. How about if we burn 1 mole of ethanol, how much of the energy will be released? So to solve this question, we can use crossover multiplication. So when we press the calculator, you will notice that the heat released when 1 mole of ethanol is burned is negative 1258.34 kilojoule per mole. So maybe you no need to write the question mark over here. You can just write down enthalpy of combustion of ethanol. Okay, so next we are going to proceed with the tutorial question 4b, at where we need to write the thermochemical equation. So basically is we want to write a chemical equation. C2H5OH liquid burn in excess oxygen will produce carbon dioxide gas and water. So 2 more of carbon dioxide, 3 more of water. So 2 times 2, 4, plus 3 times 1, 7 oxygen. And then minus here 1, so equal to 6. 6 divided by 2, here will be 3. So this is the balanced chemical equation. But the question is look for the thermochemical equation. So means that we have to add on the part of the delta H, which we already calculate is negative 1258.34 kilojoule per mole.